Hello guys, today we're going to be talking about Boolean logic. Boolean logic is a binary variable that can change from 1 to 2 possible values. So 1 or 0, true or false.
So now we're going to start talking about AND logic gates. So AND logic gates is when you have two inputs, input A and input B. If you have input A on and input B off on as well, you can get an output. Here is a real life example of AND logic gates. For example, on your computer, when you want to get a capital case letter, you need to press the shift button and you need to press the letter that you want to make a capital. So shift is input A and the capital letter is input B. So if you press both of them at the same time, you get an output of an uppercase letter.
So now I'm going to demonstrate Boolean AND logic gate. So to start with, I want a capital letter. So I have to press two buttons. The shift button and the letter of my choosing to make a capital. But if I only press one of them, it will not work. I have to press this and that to make it work.
So now we have an AND truth table. So now we're going to show you if two inputs are on or off, what is your output. So let's start with an input A that is off and an input B that is also off. What would that give you? Pause the video and think about that, and then reopen the video and see if you're right. Okay, I think you have paused the video, and if you have seen the correct answer, it is off. You don't get anything, because AND gates only work when two things are on. So now, the next one, you will do the same thing, hopefully. So what you see is that input A is on whilst input B is off. Do you think that will work? Pause the video and see. Okay, by now you should have paused the video. So, as you remember, that input A and input B both have to be on, so an AND output can work. So that is also off. Now for the next one. You have an input A of 0 and an input B of 1. So off and on. So pause the video and check. So the answer is off, because yet again, both have to be on. Now, for the final one, 1 for input A and 1 for input B. This means input A is on and input B is on. So pause the video and guess the answer. The answer is yes. You will get an on output. So let's just go over these again. Off, 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 on.
So now we are going to start talking about NOT logic gates. NOT logic gates basically mean the opposite. So not this but that, or this not that. So as you see here, we have one input and one output. Now here's a real life example of NOT logic gates. For example, the switch. If it is off, you can turn it on. If it is on, you can turn it off. As you can see here, we have a switch. So basically, it's with one switch, you can turn it on or off. This is a demonstration of a NOT logic gate.
So here is a truth table. A NOT truth table to be exact. So as you remember, the NOT truth table works by opposites. So if you have 1 and on as your input, you would have a 0, an off, for your output. Now, you can figure out the next one by yourself. So pause the video and see if you get the answer right. Hopefully you have paused the video. The answer is on, because as we said, it's the opposite. So on, not off. Or logic gate. So to start with, basically, if you have one input on, your output will work. And the same thing with the opposite way. If you have the other input on, your output will work. And also, if you have both on, still your output will work. Now here is a real life example. Let's say that you have 2 alarms in your house. One from the window, one from the door. Let's say input A is for the door and input B is for the window. So, if one of the alarms triggered, it will make a sound. If the other one from the window triggered as well, it will also make a sound. If both alarms were triggered, both of them will make a sound. So here we have an OR truth table. So if A or B are on, the output will be on. For example, the first one will not be on because both of them are off. Now for the second one, I want you to pause the video and think of the answer and then resume and see if your answer is correct. Okay, hopefully you have paused the video. And the answer is actually on. Because as we said, if one of them is on, that means your output will be on, even if the other one's off. Now, for the next one, is the same thing. It will be on. Because one of them is on, and the other is still off, but still one of them is on. Now, for the next one, both of them are on. So I want you to pause the video and think about that. Hopefully you have paused the video. Now, if you have 2 inputs on, you will get an output of on as well. So let's just go through them quickly. Off, on, and on. So now we're going to start talking about logic gate circuits. So here we have a logic gate circuit. This is the AND logic gate circuit. So here we have 2 switches. We could say them as input A and input B. And then we have a light bulb. We could say this as our output. It's either going to be on or off. So to get an on output, you need both of your switches to be on. So basically, let's use our method that we have used to make this simpler. Let's use the capital letter method. So you have to press the shift button on your keyboard and the letter that you want to make a capital to get a lit light bulb. But here, you have not pressed any of them, so you will not get a capital letter. But here, you have only pressed on one, the shift button, but you have not pressed on the letter button. So you will still not get a capital letter. But here, you have pressed on both of them. So, since you pressed both of them at the same time, you will get a capital letter. So here, our circuit is working, whilst here, it is not, whilst here, it is not as well. So you have to have 2 inputs that are on to get an on output. So now, we're going to start talking about OR, logic gate circuits. So as you see here, we have an OR circuit. But only one switch is on. Unlike the AND circuit, you only need one switch. Because you see here, the wires connect to the bulb. Sure, it is only from one side, but it still connects. The other side doesn't. But that is okay. You can remember this by our example. Remember about the alarm? So basically, we have a window alarm and a door alarm. So the door alarm is not triggered, but the window alarm is triggered. So since the window alarm is triggered, you will receive a sound or a signal telling you that. Okay, so now we're going to start talking about not logic gates. So here, as you see, we have a switch and a light bulb. As you see, the switch is not on, but the light bulb will be on. To make this simpler, let's go back to our example that we used. The switch, the actual switch in real life. Remember when we said that you have one input, one switch to use. It's either on or off. So basically, it does the opposite of the other. So here, as you see, it is off. But like that, the switch will be on. But here, the switch is on, so the light will be off. So basically, not circuits work the opposite way.
Common mistakes. People normally make mistakes between AND gates and OR gates. Reason being, AND gates have two inputs and one output, and OR gates also have two inputs and one output. But the most common mistake made between AND gates and OR gates are the shape. So AND gates, you could tell, look like a D, and then OR gates looks like a slightly curved D, but also it actually looks like a shield if you turn it 90 degrees clockwise. And yeah, thank you. Common mistakes of a NOT gate. Common mistakes of a NOT gate are not drawing the circle at the end when you're drawing it in a circuit. This turns it into something else.
Another example of a common mistake that happens between the logic gates is the circuit of AND and the circuit of OR. The difference is that AND can only work if both switches are connected. They have to make a line to the lamp. But here in the OR circuit, one of them has to, as long as it connects. Like here it cannot connect because this is off, but here it can. So people sometimes draw the OR circuits like AND circuits. Also, there is another common mistake that happens. Sometimes people miss out the circle in the logic gate of NOT. This is wrong because then it will not be a logic gate anymore. Please make sure to check out Binary Part 2 when it comes out. And please subscribe and like and comment, and have a good day.